Hi, everybody. Happy St. Patrick's Day. We are back with quadratic word problems, day 2. And again, we're going to be looking at word problems and trying to identify exactly what information the question is asking us for. So, some things to consider. The vertex is the turning point. That's going to be our maximum or our minimum point on our graph. The x-intercepts is where we cross or touch the x-axis if we're looking at a quadratic on a coordinate plane. This is also as far as word problems go. Our x-intercepts typically tell us a lot of times it's some sort of time frame, how long something has been in the air, etc. And then we also have our y-intercept, which is when our x value is 0. It's when we cross or touch the y-axis if we're looking at a coordinate plane. And the y-intercept typically tells us some type of starting point. So it's typically starting height in many of the problems we're going to be looking at today. But, it's basically some type of starting point when it comes to quadratics. All right, so let's jump in. So question 1, researchers conducted an experiment to determine temperatures at which people feel comfortable. The percent, Y, of test subjects who felt comfortable at temperature X in degrees Fahrenheit can be modeled by Y equals negative 3.678x squared plus 527.3x minus 18,807. All right, so here we go. At what temperature, or I should say, what temperature made the greatest percent of test subjects comfortable? Okay, so let's think about this question for a second. So it says, okay, it says what temperature? Okay, so which variable represented temperature again? Our x. So our x value is what we're looking for. So we're looking for an x value here. Made the greatest percent. So greatest percent refers to a max value. And the maximum again is the vertex of test subjects comfortable. Okay, so it looks like we are looking for the x value of the vertex and we're going to round to the nearest tenth when we find it. So in order to find the x value of the vertex, we're going to use the axis of symmetry formula. That symmetry again is x equals negative b over 2a. All right, so looking at our quadratic, our a value is always attached to x squared, our b value is always attached to x, and our c value is always our constant. So x equals negative b over 2a, that's negative our b value here, which is going to be 527.3, and we're going to divide that by 2 times our a value, which is negative 3.678. All right. So we simplify a bit here. I'm going to bring this up over here. So x equals negative 527.3 divided by negative 7.356. Oopsies. All right. Okay, so actually dividing that out, I get an x value, and if I round here, of 71.7. So let's interpret this for a second. So what temperature? Okay, so this is a temperature. Looking at my problem, it's in degrees Fahrenheit. So my final answer would be 71.7 degrees Fahrenheit. So that's the temperature that the greatest percent of test subjects feel comfortable. All right, so part B. At what temperature? At that temperature. So at that temperature, the one that we just found, so that's when the temperature or our x value is 71.7. Okay, so just writing notes to myself here. At that temperature, what percent? Okay, so what percent deals with technically the y value here? So what percent felt comfortable? Okay, so This is in reference to the previous problem, and if you remember, we were talking about the greatest percent of test subjects, and greatest again refers to the vertex. So now, instead of finding the x value of the vertex, we're going to use the x value to find the y value of the vertex. So just to make a note to myself, y value of vertex. Okay, since I have my x, I can just plug that in and solve for y. I know you can always use your calculator here as well, but we are just trying to get some answers algebraically to learn how to plug in the numbers and find them by hand. Our calculator is wonderful to check our answers when we're done. Okay, so to solve for y here, I am going to plug in 71.7 everywhere I see an x. Okay, so simplifying here, I get y equals negative 18,908, and I'm just going to go out to about 5 decimal places here. I know it does continue on for a while, but if we're rounding to the nearest tenth, I should get a pretty clear picture of my final number if I go out about 5 places. Plus 37,807.41 minus 18,807. Okay, oh good gracious. So adding and subtracting here, we come up with a y value of 92.2 if I round to the nearest tenth. All right, so what does that mean? So it's asking me for what percent felt comfortable. So what percent of test subjects? So 92.2% of test subjects felt comfortable when the temperature was 71.7 degrees Fahrenheit. So that's what our vertex is telling us. All right, let's take a look at number 2. A science class launched a ball off of a roof of a 23-story building and launched an 8.8-pound shot put straight up into the air. The motion, it should say is described by the following function, where h represents the height in feet of the shot put above the ground with respect to time in seconds. So it looks like we are launching this shot put off of a 23-story building. So it's not starting on the ground. Keep that in mind. All right. So h represents the height in feet of the shot put above the ground with respect to time in seconds. All right. So after how many seconds does the shot put hit the ground? So let's see what we're looking for here. After how many seconds? All right, so after how many seconds refers to time. Time is represented by t. Okay, so we're looking for t here. After how many seconds does the shot put hit the ground? Okay, so let's think about this for a second. If the shot put is on the ground, it has a height of 0, right? There's no height to it. So when we say hit the ground, it's giving us a height and it wants us the time that goes along with that height. Well, when our height is 0 and we're solving for t, so if we set up this equation, I'm going to plug in 0 for h of t, and I'm just going to write this out here, and this will give us a better idea of what we're looking for. So I have an h, I'm trying to find t, and in this case when h is 0, I'm trying to find the x-intercepts. I'm trying to find where we're crossing or touching the x-axis here. So I'm going to solve for t. Now to do that I'm going to factor. So first thing, I'm going to take out this GCF of negative 16. And again, you can also divide every single term by 16 on both sides of the equal sign, and that will make 16 disappear altogether. So you can do it either way. It does not matter. Just make sure that when you divide, or if you're going to divide, you divide every single term by negative 16 on both sides of the equal sign. Okay, so here I'm going to AM factor. I'm going to find two numbers that multiply to negative 15 but add to negative 2. In this case, those numbers are negative 5 and positive 3. Okay, now to solve for t, I'm going to set up my walls here, and I am going to apply the zero product property, where I'm going to set each piece of multiplication equal to 0. And where I'm able, I'm going to solve for t. Okay. All right, so I end up with t equals 5 and t equals negative 3. So we have to keep in mind that t refers to time in seconds. So if we're trying to figure out after how many seconds does the shot put hit the ground, it doesn't really make sense for that time to be negative. It doesn't make sense for it to be negative 3. So in this case, unfortunately, we're just going to not use that negative 3, and we're only going to look at t equals 5. So in this case, after 5 seconds. So the shot put is in the air for 5 seconds, and then it eventually hits the ground. What is the maximum height? So again, maximum or minimum always refers to the vertex. And in this case, when we're trying to find the maximum height, height refers to h, or the y value in this case. Okay, now in order for us to find the y value of the vertex, we're probably going to need to know the x value, or in the context of our problem, we're going to need to know t. We're going to need to know time before we can find out height. So we can find the t value, or the x value of our vertex, by using the axis of symmetry formula. So in this case, instead of saying x equals, I'm going to say t equals negative b over 2a. Okay, so plugging in my b value here, which is 32, over 2 times my a value, which is negative 16, I come up with a t value of 1. So it looks like the maximum height was reached after 1 second. That's what that t means. Okay, so now let's use that. So after 1 second, how high is the shot put? So now I'm going to take my equation, and everywhere I see a t, I'm going to plug in 1. So negative 16, 1 squared, plus 32 times 1, plus 240. Okay, so simplifying, negative 16 plus 32 plus 240. And if I add and subtract everything there, I get 256. So let's interpret what we have. So what is the maximum height of the shot put? The maximum height of the shot put is going to be this 256 feet. And when is that height reached? After 1 second. So the shot put will reach, so let's see, the shot put will reach a max height of 256 feet. Always make sure you remember your labels with these. Okay, what is the value of h of 0? So think about with this one, your function notation, what does that mean? What is the value of h of 0, and what does it mean in the context of this problem? So h of 0 means we are plugging in 0 for t everywhere we see it. So h of 0 means everywhere I see a t, I'm going to plug in 0. So h of 0, when I simplify, is 240. So what does this mean? So obviously we found a height. The 240 represents 240 feet. 0 represents time in seconds. So at 0 seconds, we're 240 feet off the ground, or the shot put is. So what does that mean? It means, if we go back to our problem, we talked about throwing the ball or the shot put off of a 23-story building. So that 23-story building is 240 feet high. So the height of the building is 240 feet. That is where the shot put is thrown from. That's its starting height. All right, let's keep going. A kernel of popcorn contains water that expands when the kernel is heated, causing it to pop. The equations below give the popping volume, Y, in cubic centimeters per gram, of popcorn with moisture content X as a percent of the popcorn's weight. So we're looking at hot air popping and hot oil popping, and we'll have to distinguish when to use each equation given the problem. So for hot air popping, okay, what moisture content maximizes popping volume? What is the maximum volume? All right, so what moisture content? So this is asking us, if we look back in our problem here, it's asking us for an X value. And specifically, it's what moisture content maximizes. So again, maximizes means vertex. So to start, we're going to look for the X value of the vertex. The second part of this problem, when it says what is max volume, maximum volume refers to the Y value of the vertex. Again, maximum, minimum means vertex. Okay, so let's start by finding the X value of the vertex, and then we can go ahead and find the Y value. So just kind of giving me a little idea as far as what A and B and C represent in the problem, I'm going to go ahead and use the axis of symmetry formula. So negative my B value, which is 21.4, over 2 times my A value, which is negative 0.761. Simplifying this, now I'm going to round to the nearest, I think I'm going to round to the nearest hundredth because all of these are going to be some pretty large decimals. So let's keep it rounded to the nearest hundredth with these questions. So when I simplify this, if I'm rounding to the nearest hundredth, I get 14.06. So to answer the first question, what moisture content maximizes popping volume? Remember, the moisture content is a percent of the popcorn's weight, so 14.06 means 14.06%. I'm just going to draw a little line here to do the second part of the problem. What is the maximum volume? Okay, so to find the Y value of the vertex, we've got to use this X value that we just found. So plugging in 14.06 everywhere I see X, I can solve for Y. Oh, get out of there. All right. All right, so looking good here. So simplifying. Again, just basically plugging this all right into your calculator. I end up with 55.65, and again, this is rounding to the nearest hundredth. So what does this mean in the context of the problem? Y represents the popping volume in cubic centimeters per gram. So we're going to say 55.65 cubic centimeters per gram. Okay, so this is going to be our vertex. This is the maximum moisture content and volume. All right, looking at B for hot oil popping. Okay, so let's switch it up a little bit here. For hot oil popping now, we're going to use the second equation that was in our problem here. So just to label, because I'm sure I'm going to need it, A, B, and C. What moisture content maximizes popping volume? What is the maximum volume? So exact same questions, we're just using the hot oil popping equation versus the hot air popping equation. So let's go ahead. This part here, is the x value of the vertex. That's what we're going to find first. And this guy is the y value of the vertex. Okay, so we got to start with x. So plugging in to my axis of symmetry formula, x equals negative my b value, which is 17.7, over 2 times the a value, which is negative 0.652. Again, round to the nearest hundredth with each one of these problems. So if I'm rounding to the nearest hundredth, I'm going to say x equals 13.57. Now, interpreting what that means in the context of the problem, 13.57 is the maximum moisture content. And again, that is represented as a percent of the popcorn's weight. So we're going to say 13.57%. Okay. So moving on from there, if I'm looking at finding the maximum volume, then I'm going to take that maximum moisture content, I'm going to plug it in for x and solve for y. So everywhere I see x, I'm going to plug in 13.57. Now if you have your graphing calculator, these calculations are nice and easy. You can type them right into your calculator the way we're writing them down and just hit enter. Now rounding to the nearest hundredth, I get 44.13. Okay, so that's going to be the maximum volume. So again, to write that out, 44.13 centimeters cubed per gram. Okay. All right, so that does it for question 3. Popping down to question 4. Fishing spiders can propel themselves across water and leap vertically from the surface of the water. Lovely. During a vertical jump, the height of the body of the spider can be modeled by this function, where x is the duration in seconds of the jump and y is the height in millimeters of the spider above the surface of the water. After how many seconds does the spider's body reach its maximum height? Okay, there's that word again, maximum. So we know we're referring to the vertex. Now let's figure out which part, the x value or the y value. After how many seconds? All right, seconds refers to duration, and that is going to be our x value. So we are trying to find the x value of the vertex. And remember, we know how to do that. We've been doing it all along. We're going to use the axis of symmetry formula. Okay, so plugging in, I get x equals negative my b value, which is 820, over 2 times a, which is negative 4,500. I don't know why these boxes keep showing up. Sorry about that. And that gives us, and again, we're going to take this problem, we're going to round to the nearest hundredth, just like we did in the previous problem. So if I do that, plugging all this in, I get an x value of 0.09. So you should have gotten 0.091 repeating. And again, we're just going to round this to the nearest hundredth, and we're going to say x equals 0.09. So this x value again is time, it's duration in seconds. So this is 0.09 seconds. Okay. What is the maximum height? Well, in order to find the maximum height, we've got to use the amount of time it takes to reach that max height, which is what we found in the previous problem. So to find the max height, which is the y value of the vertex, I got to plug in that x value of 0.09. So let's go ahead and do that. So y equals negative 4,500 times 0.09 squared plus 820 times 0.09 plus 43. Okay. All right, so again, if you've got your graphing calculators, you could basically stick this right in and hit enter, and it's going to do all the calculations for you right away. If you don't have a graphing calculator and you kind of had to go piece by piece, this is what you're going to be looking at. And that gives us, if we're rounding to the nearest hundredth, 80.35. All right, so the maximum height is 80.35 millimeters. So putting this all together, the fishing spider can propel itself 80.35 millimeters after 0.09 seconds. All right, so that is it for today. Feel free to email Mrs. Hayward or myself if you guys have any questions, and we'll be going over some more notes soon. All right, have a great night. I hope you guys had a great St. Patrick's Day.